Okay, this is EOC review of tough ones again. Okay, so I have ADE, which is the green triangle, and we have a pink triangle, ABC, which encompasses the green triangle, and we got to figure out what is the length of AC. Okay, so we got to look at, let's define AC and AD. Before we do that, this is going to be, we'll say that this side is this leg, and this side is that leg. Okay, and this will make sense in a second. Okay, but let's define this leg as for both of these. Okay, so let's define AC. AC equals, where'd my green pen go? Pause this for a second while I find my green pen. Okay, so AC equals AE plus EC. It's going to equal 5 plus 4x plus 3, which equals, this AC thing is going to be 4x plus 8. Okay? And then we have AB, that's that side. AB, that leg, equals AD, which is green, AD, plus DB, which equals 4 plus 5x minus 3, plus 5x minus 3. Okay, so we have AB ends up equaling 5x plus 1, because 4 minus 3 is 1. All right, now we can set up a ratio. Okay, I'm going to set up a ratio here. Okay, so we're setting up a ratio of similar triangles. Okay, and let's set up our green triangle up here and our pink triangle right here. Okay, so this is going to be the pink triangle and the green triangle, pink and green, and we're going to be that leg, be that leg, and then this leg. Okay, so that leg in the green triangle is 4, and this leg on the green triangle is 5. Okay, and the pink side, we're going to be doing that leg on the pink side is AB or AC, which is 4x plus 8, and that leg, whoops, that was the wrong leg. See, that's why I do it. That's why I did it. I made a mistake. So that leg on the pink side, that's that leg. AB is that leg, and this is this leg. This leg and that leg. All right, so that leg on this side is 5x minus 3. Nope, that's not right either. Man, this is why I do it. That's why I do it. All right, so that leg ends up being 5x plus 1. 5x plus 1. What's 5x plus 1? Make it legible. 5x plus 1. And then this leg is 4x plus 8. 4x plus 8. So this is 4x plus 8. That's this leg. And this leg was 5x plus 1. 5x plus 1. All right, so now we just cross multiply. Turn all this purple. All right, so 4x times 8 is 16x plus 32 equals 25x plus 5. All right, this x goes over here. It's going to subtract x, going to make it 9x. And that's going to subtract x from here, goes 27. So x equals 3. And that's going to be our x. So now that we know x equals 3, that x can go back into this AC, right? X is going to be back into this AC, so 4 times 3 is 12 plus 8 equals 20. So that is what this line segment AC equals 20. Equals 20. Okay, so you could also see here 4 times 3 is 12, plus 3 is 15, plus 3 equals 15, 15 plus 5 equals 20. Also works. Okay, there's that one. All right, number 27 was a tough one for some people. We've got to find out line at x plus 2 equals 10, x plus 2y equals 10, center point goes through negative 2y. All right, so let's first find the let's make this in y equals mx plus b form. So 2y equals x, negative x plus 10. And we divide both sides by 2, making it y equals 1/2 x, negative 1/2 x plus 10. So we know that this line, oops, not plus 10, plus 5, divide both sides by 2. All right, so this line intercepts the y-axis at plus 5, has a slope of, goes down 1y, goes over 2x, goes down 1y, goes over 2x. So that is our line segment. That's our line for this. That's our line. Okay. Then we have a circle, right, located at 2, and then negative 1. Okay. And we've got to find the tangent point. We know it passes through this line to negative 1. So let's build an equation that matches this. Okay, so it's going to be, we know a tangent point is, tangent point intersects, well, the tangent point intersects a radius at 90 degrees, right? So a line that possesses this radius would have a opposite, and negative slope, right? Our slope is that, so our slope of this line would be 2x, right? So y would equal 2x, right, plus some y-intercept. Well, we know it goes through this line. You know, it goes through that point, so let's take that point and plug it in here to figure out what our b value is. All right, so we're going to take this negative 1 for y, negative 1 equals 2 times 2, which equals, or is plus b, and we'll solve for b. That's going to be 4 minus 1, so that's going to be equals negative 1 equals 4 plus b, right? So 4 is going to go over here, so it's going to be negative 5 equals b. So our b-intercept is 5. So y equals 2x minus 5. Okay, so we know our b-intercept for this is way down here at negative 5. All right, so we can go ahead and draw our line right here to our b-intercept like this, and that's our b-intercept. Okay, and if we're not really sure, and it's not completely obvious where our y-intercept is, we can take, we'll say, our x value from here, take our x value from this point, all right, or actually, let's take this line, right, this x value, make it match this y value, because where these points equal each other, right, where these lines equal each other, where those lines intersect. So we're going to say negative 1/2 x plus 5 equals 2x minus 5. Multiply both sides by 2 to get rid of this value of negative 1/2 x. So it's going to be negative x plus 10 equals 4x minus 5. Right, so bring this x over here, it's going to be 5x. Bring this over here, right, and that's going to become 15, so x equals 3. Okay, so our x value for our coordinate point is going to be 3. Now we bring this thing in here and drop it in back into that, right? Y equals 3 times 2, or 2 times 3 rather. Let's do this in pink, I guess. So y equals 2 times 3, which is 6. I made a mistake. Hold on, let me look. I made a mistake in my algebra. Let me go back to here. Let me rewind here. Forgot to multiply this. This should be 10. That's 10. Okay, so now this is going to go back here, and this is going to be 5x equals 20. So x equals 4. That makes more sense. So my x value is going to be 4. So let's drop this in here, make that 4. So it's going to be x minus 5. Sorry about that. All right, so it's going to be 4. That's going to be 8 minus 5. My y value is going to be my y value is going to be equal to 3. All right, so it's going to be 4 comma 3 for my x point, and you'll see my intersection point is going to be 4 comma 3. All right, so that's going to be where my tangent point meets. All right, so in case you were wondering, my radius length. This is my radius length. This is my radius of my circle, and it's 2 over, and it's looks like it's 4 high. All right, so this is going to be 2 squared. This is going to be square root of 2 squared plus 4 squared, which is 4 is the square root of 20, or 2 square root of 20, 2 square root of 5. All right, so that's the length. That's the length of my radius. But it didn't ask that. So this circle is going to look something like this. Something like that on my graph. Okay, there's that one. Sorry about the algebra error there. All right, so number 43 says a decagon. A regular decagon has an area of 24.3 square meters. Determine the length. All right, so here's a decagon. But what's important of this whole thing is this is a regular decagon. Okay, and if I have a regular decagon, okay, or any regular polygon for that matter, the lengths are the same length. The length of the sides. The length of the sides. So regular. So in a regular polygon, angles are same. So all these angles are the same, okay? And the lengths of the sides are same. Okay, that's 2 things you need to know about regular polygons. This is a regular decagon, so it has 10 sides. Okay, that's one thing you need to take away from this question, from this. Okay, is that these all have the same length. Okay, another thing you need to know is that the area of a regular polygon. Area of a regular polygon equals, it's going to be equal the number of, I should write this here. I write it somewhere else. It equals the area of a regular polygon equals the number of sides, in this case it's 10, times the length of the sides times the length of the apothem divided by 2. All right, so let me talk about some stuff here, and so this will make sense in there in a second. All right, so some relationships within a regular polygon. Okay, if you go from one corner, one angle to the other angle that are on the opposite sides, in this case it'd be these two, right? So these two angles, and then these two angles, like this, like this. These two angles intersect at the center of the polygon, okay? And this angle, the vertical angles formed here, right? The relationship is that angle there, the measure of that angle equals 360 degrees divided by the number of sides, or the number of angles, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or the number of angles, or 360 degrees divided by number of angles, okay? So in this case, it's 360 degrees divided by 10 is 336 degrees, okay? So that's a relationship right there, okay? All of these angles, so all of these angles are 360 degrees divided by 10, okay? So is that angle there. Okay, the apothem, I'm going to make it red here. The apothem is a line that's dropped directly from the center point to a line that bisects, so this is 5.4, so we're looking at like 2 point, what's the middle, maybe like there, okay, line that bisects the midpoint at a 90-degree angle. So a perpendicular bisector, looking for a perpendicular bisector of the, that's way off. That's way off. That's like 2.5, and that's like 3. That's way off. Looking for a perpendicular bisector. I'm just gonna eyeball it. I was right the first time. Perpendicular bisector of, man, I keep missing. Perpendicular bisector of the mid-segment. So like right there, I guess. Okay, we're gonna say that this and this are the same length, okay? So remember, all these lengths are the same. So these lengths are the same too. This is the mid-segment here, so this is the midpoint. Means that this is the length of the side divided by 2, and this is the length of the side divided by 2, and this is a 90-degree angle, right? So this red angle here would be 36 divided by 2, which is 18 degrees, okay? And this angle and this angle are congruent, okay? So if this is a isosceles triangle, right, that should not be red, that should be purple. This is 36 degrees, right? That's 36 degrees, so 180 minus 36, right? 180 minus 36, 180 minus 36 is 144 divided by 2. Each one of these is 72 degrees. 72 degrees at each one of those, okay? So that's 36, that's 72. Anyway, and you would have been able to figure that out because that's 18 degrees. 18 degrees plus, it's 90. So there you go. So that is the relationships that exist all here, right? It's a right angle, short leg. A long leg is the apothem. The apothem is a long leg. And then this is the hypotenuse. That's the hypotenuse. But either way, if you wanted to solve for the length here, right, you know, they gave us the area of 24.3. This is 24.3. number of sides is 10, right? We're trying to figure out the lengths of the sides. Right, let's put the length of the sides in terms of the length of the apothem in terms of the length of the sides. Okay, so in order to do that, let's use tangent. Okay, so the tangent, the length of the apothem in terms of tangent. Okay, so this, the tangent of 18 degrees, we'll go on the bottom here, and length of sides is divided by 2 is this. We're going to put 0.5 times the length of the side, right? Because the tangent of 18 degrees equals the opposite 0.5 length of the side over the length of the apothem. So that equals that. So this equals 0.5 divided by the length of the apothem, which is 18 tangent, which is, so this is 1.54 the length of the side. Okay, so now I can take this and say this is the length of the apothem, and just put in 1.54 the length of the side divided by 2. Okay, turn that into 5, right? So I'll have 24.3 equals 7.7, because this times 5 is 7.7. Lengths of the side squared is that. Divide both sides by 7.7, so 24.3 divided by 7.7 equals, so 3.15. 6, I guess, 3.16 equals the length of the side squared. Take the square root of that. So the lengths of the sides equals 1.76. I think this is meters, I guess. Yeah, meters. Right, so that's how you figure that one out.